everyone. This is a very brief look at calculus, number 13. This is the friendly review, or Amiga de Vista. And the first thing is write the equation of a line through this coordinate 3, 7, and the slope of 2 in the point slope form. And I give you the point slope form here. All I want to do is set up a template, y minus something equals something times x minus something else. And I'm just going to fill that in with the given information. So this is some PERT skills here maybe. This is x sub 1, and this is y sub 1. And it gave me the m right here. It gave me the m, 2. So my y sub 1 is 7. That just falls in. My slope is 2. That just goes over there. And then my x sub 1 is 3. And that's it. That's the answer to it. Just put it in that format. The information's already given, and we roll with it. Now, this is calculus. This is a little different. So it wants me to find the derivative of f of x. So the derivative is going to equal, well, we're going to use the power rule. I have to do 2 times 3, or 3 times 2. That would give me 6x. And then don't forget the power rule. You subtract 1 from that, so that would give me 6x squared. And then the derivative of 4x is just 4 plus 4. And now, that's the derivative. What it wants me to do now is find the slope. And the derivative is the slope at a point on a curve. So they want me to find the slope at the point 1. So I have to take this point 1 here, that x value 1, and bump it in to my derivative. So that's going to give me 6, which is the derivative, parentheses something squared, plus 4. And what I'm going to put in there is that value 1. So 1 squared, that's 1, times 6, that's 6, 6 plus 4. So the slope is going to equal 10, 6 plus 4. So for part C, write the equation of the tangent line at 1, 6, so I have a point. And now I have a slope. In the form of the point slope form. So I like to write my point underneath it here sometimes. 1, comma, 6. And I like to write my slope right under here to make it all nice and convenient. Slope equals 10. And then I'm going to come over and do my template. Y minus something equals something times x minus something else. And now all I have to do is fill that in. I'm going to fill it in with my 6, my 10, and my 1. And that's your answer. Not too shabby. This is another derivative problem. However, it's got some trick. That makes it a little bit more tricky. So the first thing it wants me to do is find the derivative of sine x. So we have our little note. I'll write down the note. Sine, the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of negative sine x is negative cosine x. The derivative of that is back to sine x, and it's this vicious cycle. I like to put a little arrow going down and say that these are derivatives. But in this case, they're also going to be called slopes. Okay? So the derivative of sine x for part A is going to just go from sine up 1. So the derivative of sine, derivatives are going down. So that was an antiderivative. The derivative of sine x, I go down 1. So that's going to give me f prime of x just equals cosine x. And that's part A. Part B, now it gets a little bit more involved. Part B, it wants me to find f prime of pi over 3. So f prime of pi over 3 of cosine x. So what I want to do is take that pi over 3 and plug it in. Hopefully you all know what pi over 3 is, cosine of pi over 3. Well, if you don't know what cosine of pi over 3 is, if you come over here to the cosine and then scroll over to pi over 3, cosine of pi over 3 is going to be 1/2. So that means cosine of pi over 3, the slope is going to equal 1/2. I have a point, pi over 3, comma root 3 over 2, and I have a slope, 1/2. So I'm going to come over here, and I'm going to write my point slope form. So underneath this coordinate, underneath this y minus y sub 1, I like to write my coordinate pi over 3, comma, root 3 over 2, and my slope equals 1/2. Now I'm going to take that and run with it. Y minus something equals something times x minus something else. And I just want to plug in these values. So the root 3 over 2 comes down. The 1/2 is my slope. It's right there. And the pi over 3 comes way over here. Antiderivative from 0 to 2 of 6x squared dx. So the first thing I want to do is take the antiderivative. So the opposite or the anti of subtracting 1 from the exponent is adding 1. So that's going to give me 6x cubed. Then the opposite of multiplying by the exponent is the anti is divide by the exponent. And simplified, that's going to give me 2x cubed. Now I want to evaluate that. I want to evaluate that from x equals 0 to x equals 2. So that's going to give me 2 times 2 cubed, and then 2 times 0 cubed. 2 times 2 cubed, 2 to the third is 8. 8 times 2 is 16. And then the 0, 0 cubed is 0, that equals 0. And now the calculus is just 16 minus 0, so my answer is going to equal 16. Not bad. So let's run the note somewhere. So the note is sine x. The derivative of sine x is is cosine x. The derivative of cosine x is negative sine x. The derivative of negative sine x is negative cosine x. The derivative of negative cosine x is sine x. And these are derivatives coming on the way down. So that means if they're derivatives on the way down, they're antiderivatives on the way up. And we're going to use that. We're going to use that. So if I come over here, it asks me what the antiderivative of cosine x is. So the antiderivative of cosine x, I go up 1, and that's going to give me sine x. So I'm going to write down sine x over here because that's the antiderivative of cosine x. Now we have to evaluate this from, oops, I erased the sine x. That's sine x. Now we have to evaluate this from pi over 2, x equals pi over 2, all the way up to 3 pi over 4. So we're going to evaluate what sine of 3 pi over 4 is. So let's see what 3 pi over 4 is for sine. So I scroll over to 3 pi over 4, and sine of 3 pi over 4 is root 2 over 2. So that's going to equal root 2 over 2. Now I want to figure out what sine of pi over 2 is. Sine of pi over 2. So let's see. I'm going to go over to pi over 2, find out what pi over 2 is. Sine of pi over 2 is 1. So I put a 1 here, and then here comes the calculus. The antiderivative is going to be root 2 over 2 minus 1. And that's my answer in exact form. Note, for the secant tan antiderivative, I have it written down all over my room. And it goes like this. Secant tan. And what this means is that the derivative of secant is secant tan. If I wanted to know the derivative of tangent, it would be secant secant. So since the derivative of secant is secant tan, the antiderivative of secant tan is going to be secant. And I'm going to be evaluating this secant from 4 pi over 3, the lower bound, to 5 pi over 3, the upper bound. Now, I still need the unit circle table. So I have to look at the secant row, and secant of 5 pi over 3, secant of 5 pi over 3. I'm going to scroll over. I like how I have it down here also. Secant of 5 pi over 3 is way over here. Secant of 5 pi over 3 just so happens to be the nice number of 2. Now I need to find secant of 4 pi over 3. Let's see what secant of 4 pi over 3 is. So I scroll over until I find 4 pi over 3. There's 4 pi over 3. Secant of 4 pi over 3 is negative 2. Here comes the calculus. It's going to be 2 minus negative 2. So my answer is going to equal 4.